Dear interstellar traveler, please close your eyes. Let your breath gently synchronize with the heartbeat of Earth. This is a scientific harbor for souls yearning for peaceful sleep. Tonight, let us spread a gentle blanket of knowledge across the vast sea of stars. The sleepy fact you are about to hear are like specks of thought dust drifting in the cosmic depths. Did you know Jupiter continuously plays an infrasound symphony with frequencies 1,000,000 times lower than the human hearing threshold? The pulsar in the Crab Nebula flashes every 33 milliseconds, a cosmic timekeeper more precise than an emerald pocket watch. These relaxing astronomy facts will weave into the most unique calming space documentary, projecting a personalized space documentary for sleep deep within your consciousness. When we look up at the sky on a clear night, we see a sky full of stars, yet between the stars lies endless darkness. At this moment, you might not wonder why the night sky is dark, because many people would think that during the day, with sunlight shining, it is bright, and at night, as the Earth rotates away from the sun, there is no sunlight, so the sky is dark. However, the reason cannot be explained so simply. In fact, as early as the beginning of the 19th century, a German astronomer named Heinrich Wilhelm Olbers raised this very question, known as the famous Olbers paradox. He believed that if our universe were static, infinitely old, infinite in size, and filled with countless stars like the sun that emit light, then no matter which direction you look, your line of sight would eventually fall upon a star. According to this logic, every part of the sky should be lit up, just like during the day. But in reality, why is the night sky we see still dark? This is Olbers' paradox, a classic and fascinating topic in astronomy. At that time, this problem puzzled astronomers for nearly 100 years. Now, with humanity's growing understanding of the universe, we can explain why the night sky is dark. This is because Olbers' paradox relies on several premises. First, the universe is static and steady state. Second, the universe is infinite in both age and space. Third, the distribution of stars in the universe is uniform. However, in the early 20th century, the American astronomer Edwin Hubble discovered that our universe is not actually static and steady state. Through telescopic observations, he found that most galaxies are moving away from us, and their recession speed is proportional to their distance, meaning the farther away a galaxy is, the faster it recedes. From this, he concluded that our universe is actually expanding. Because the universe is constantly expanding, when light from distant stars travels to Earth, the light waves are stretched. This causes a decrease in the energy of the light. This effect means that the light emitted by these stars becomes very faint before it reaches us, eventually falling below the detection limit of our eyes. Furthermore, through the expansion of the universe, we can also infer that the age of the universe is finite. In 2013, the European Space Agency's Planck satellite measured the universe's expansion rate to be approximately 67 kilometers per second per megaparsec. Based on this expansion rate, it's calculated that our universe was born about 13.8 billion years ago. This means that light also limits the size of the observable universe. Beyond the observable universe, the expansion speed exceeds the speed of light. Therefore, only light emitted within this time frame can be observed by us. Outside the observable universe, Light from celestial bodies can never reach Earth, so the number of celestial objects we can see is finite. In addition to the above, the lifespan of stars is also finite. It's important to know that stars cannot exist forever. They have their own life cycles. When their fuel is exhausted, they die. Many stars may have already died before their light reaches us. Secondly, dust and other matter in the universe can absorb and scatter light, making the light from distant galaxies even fainter. From the above, we understand that the reason the night sky is dark is due to the expansion of the universe, the finite age of the universe, the finite lifespan of stars, and the presence of light-absorbing matter in the universe, among other factors. When we look up at the starry sky on a winter night, we might see a star that is about to die, and when it dies, it will become the brightest star in the sky, with a brightness that can rival the full moon, even visible during the day. This star is Betelgeuse. Betelgeuse is one of the most easily identifiable stars in the sky. It is located at the shoulder of the Orion constellation and is an extremely bright red supergiant. About 640 light-years from Earth, its mass is roughly over 16 times that of the Sun, and its volume so large it could hold 700 billion suns. If we were to replace the Sun with Betelgeuse, its volume would extend beyond the orbit of Jupiter, meaning Venus, Earth, and Mars would all be engulfed by it. Betelgeuse has always been an object of interest for astronomers. In 2019, astronomers observed Betelgeuse periodically dimming and brightening in a strange way. Its brightness dropped to 36% of normal and then recovered. Later research found that this was due to large amounts of material being ejected from its surface, obscuring our view of Betelgeuse. Scientists speculate that it is currently in the final stages of its life, meaning Betelgeuse will go supernova sooner than we imagined. Although Betelgeuse is nearing the end of its life, compared to the lifespans of other stars, it is actually like an infant star. Its age is only about 10 million years. Consider that our Sun has existed for nearly 5 billion years since its birth, while Betelgeuse is only about 10 million years old. This shows how young Betelgeuse is. So why do astronomers believe such a young star is already in its final stages? We know that the burning principle of stars involves the fusion of lighter elements into heavier elements, releasing energy in the form of light and heat. However, a star's fuel is finite. For example, our Sun has been undergoing nuclear fusion in its core for over 5 billion years. Calculations estimate that in about another 5 billion years, the hydrogen in its core will be depleted, leading to its end. Betelgeuse, from its birth, had a mass over 10 times that of the Sun, so its lifespan is much shorter than the Sun's. Because a star's lifespan is inversely proportional to its mass, the greater the mass, the more violent the nuclear reactions inside, the faster the fuel consumption, and thus the shorter the lifespan. Currently, the hydrogen in Betelgeuse's core is almost depleted. It is undergoing the fusion process from helium to carbon, causing its volume to expand and become a red supergiant. Astronomers believe that once the carbon in Betelgeuse's core is exhausted, it will take only about 6 months for the entire star to disintegrate in a supernova explosion. At that point, the core will leave behind an iron core. After the explosion, if the mass of this iron core exceeds the Chandrasekhar limit, gravity will compress the atoms, forcing electrons into the atomic nuclei where they combine with protons to form neutrons, ultimately collapsing into a neutron star only about 30 kilometers in diameter. Astronomers predict that Betelgeuse could go supernova within the next 100,000 years. When it explodes, its luminosity could rival or even exceed that of the full moon, lasting for several months, visible even during the day. Then, over a few years, its brightness will gradually fade. At that time, the left shoulder of Orion will lose a star, leaving behind only a beautiful planetary nebula. In fact, as early as 1054 AD, humans witnessed a spectacular scene of a supernova explosion. At that time, the Chinese astronomer Yang Huidi recorded it, naming it the guest star. He wrote, "In the first year of the Zhe era, in the 5th month, it appeared in the east at dawn, guarding the celestial official. It was visible during the day, like Venus, with rays in for directions, colored red and white. It was visible for a total of 23 days. Afterwards, over the next 2 years, its brightness gradually faded. This guest star is now the Crab Nebula." Speaking of this, you might have another question. If Betelgeuse explodes, will it affect Earth? Indeed, a supernova explosion and threaten life within a certain range. If a supernova were to explode near Earth, its high-energy radiation could directly destroy Earth's atmosphere, exposing life to cosmic radiation, which would be fatal. Fortunately, Betelgeuse is 640 light-years away from Earth and will not significantly affect us. In the vast and boundless universe, there are all kinds of celestial bodies. Some of these bodies are extremely terrifying, such as neutron stars. Neutron stars are the densest celestial objects besides black holes. Like white dwarfs and black holes, they are products formed after the death of a star. The only difference is that they are formed from stars of different masses. According to astronomical research, stars with masses between 0.5 and 8 times that of the Sun will form white dwarfs. Stars with masses between 8 and 30 times that of the Sun will form neutron stars. So how are neutron stars formed? We know that the reason stars shine and generate heat is due to internal nuclear fusion reactions. Generally, low to medium mass stars can only fuse elements up to carbon before they can no longer continue fusion to release energy, leading to their death. Massive stars are different. Due to their greater mass, the internal pressure and temperature are higher, allowing them to fuse elements up to iron. When they reach iron, the core can no longer fuse and release energy, breaking the internal gravitational balance. The core begins to collapse inward, and the star undergoes a supernova explosion. After the explosion, if the core of this star exceeds the Chandrasekhar limit or the Oppenheimer-Volkoff limit, gravity will compress the atoms, forcing electrons into the atomic nuclei where they combine with protons to form neutrons, meaning all matter turns into a neutron state, forming a neutron star. The radius of a neutron star is very small, generally only tens of kilometers. However, its mass is incredibly large, equivalent to 1.4 to 3.2 times the mass of the Sun. Its mass per cubic centimeter can reach between 90 million and 2 billion tons. If we were to compress Earth to this state, Earth's diameter would be only about 22 meters. Besides their immense mass, and density. Neutron stars also have extremely terrifying gravity. The escape velocity at their surface can reach 50% of the speed of light. This means that even light entering its vicinity would have to follow a curved parabolic path to escape its gravity. It is unimaginable what kind of existence such a celestial body is. When we look up at the starry sky at night, the naked eye can see over 6,000 stars, apart from a very few which are planets within our solar system. Most are stars within our Milky Way galaxy. However, besides these with the naked eye, we can also see for celestial objects outside our galaxy. Today, let's talk about these for extragalactic objects visible to the naked eye. 1. Small Magellanic Cloud. The Small Magellanic Cloud is a satellite galaxy of the Milky Way and one of the closest extragalactic galaxies. It is only 200,000 light-years away from us, with a diameter of about 7,000 light-years, containing hundreds of millions of stars. If you are in the southern hemisphere, on a clear night, looking towards the constellations Tucana and Hydrus, you can faintly see a fuzzy patch of light with an apparent magnitude of about 2.7. That is the Small Magellanic Cloud. Its shape is irregular because it is too close to our Milky Way and has been gravitationally disturbed, leading to its irregular form. 2. Large Magellanic Cloud. Like the Small Magellanic Cloud, the Large Magellanic Cloud is a satellite galaxy of the Milky Way. Its shape is also gravitationally disturbed by the Milky Way. Irregular form, it is located in the direction of the constellations Dorado and Mensa, about 160,000 light-years away from us, making it the closest extragalactic galaxy to the Milky Way. Its diameter is about 20,000 light-years, containing nearly 10 billion stars. Similarly, the Large Magellanic Cloud can only be observed from the southern hemisphere, with an apparent magnitude of about 0.9, easily visible to the naked eye. 3. Andromeda Galaxy. When you look towards the northeast on a night, you will find a fuzzy elliptical patch of light with an apparent magnitude of about 3.44. This faint, shimmering patch is the Andromeda Galaxy. Early astronomers believed this patch was a large nebula within the Milky Way. It wasn't until 1920 that the famous astronomer Edwin Hubble, using the Hooker telescope, discovered a Cepheid variable star within the Andromeda Nebula. Based on the period luminosity relationship of Cepheid variables, he calculated its distance and finally confirmed it was an extragalactic galaxy. The Andromeda Galaxy is the largest galaxy in our local group, with a diameter of 200,000 light-years, about 2.5 per million light-years from Earth. It is estimated to contain up to 1 trillion stars, far exceeding our Milky Way. 4. Triangulum Galaxy. The Triangulum Galaxy is the third largest galaxy in the local group. It is located in the direction of the northern constellation Triangulum, with a diameter of about 60,000 light-years, containing approximately 40 billion stars. The Triangulum Galaxy is very distant from us, about 3 million light-years away, as it is slightly smaller than the neighboring Andromeda Galaxy and the Milky Way. The Triangulum Galaxy appears very faint, almost at the visual limit. Nevertheless, It is the most distant object visible to the human naked eye. The above are the 4 extragalactic objects visible to the naked eye. More distant ones require astronomical telescopes to observe. When we observe with telescopes, we find that galaxies like these are countless in the universe. Based on estimates from Hubble telescope galaxy data, within our known observable universe, there are at least 1 trillion galaxies. One can imagine how vast the number of galaxies is. From ancient times to the present, humans have been filled with endless reverie about the starry sky above, but in earlier times, limited by technological backwardness, we could only understand the universe with the naked eye. However, starting from the last century, with the continuous development of science and the advances in human technology and observation, we have gradually come to realize how vast and expansive the universe is. In the face of the universe, we are but insignificant specks of dust. The photo we see now is called Earthrise, was taken on December 24, 1968, by astronaut William Anders aboard the Apollo 8 spacecraft while orbiting the Moon. It was also the first time humans witnessed Earth's appearance from a distance of 380,000 kilometers from Earth. From the image, we can see Earth like a blue marble, quietly suspended in space. This made many people feel how lonely Earth is in the universe. However, this photo is nothing compared to another. On September 5, 1977, NASA launched an unmanned outer space probe, the well-known Voyager 1. After exploring the outer planets, due to a failed orbital maneuver, it deviated from the ecliptic plane of the solar system and flew outward. At a distance of about 6.4 billion kilometers, it took a set of astonishing photos. Among them, the photo of Earth was even smaller than in Earthrise. The dot we see now is Earth, occupying only 0.12 pixels of the entire photo. Therefore, it was later called the pale blue dot by the famous astronomer Carl Sagan. After this photo was released, it made many people ponder. They never realized Earth was so minuscule. Later, with more advanced observation technology, astronomers discovered that the solar system is merely an insignificant stellar system within the Milky Way. The image we see now is currently the most detailed panoramic photo of the Milky Way. It was taken by a scientific team from the University of Wisconsin using the Spitze Space Telescope. This photo took about 10 years, capturing approximately 1 million images, which were then merged into a panorama encompassing over half of the Milky Way stars, numbering at least 100 billion. But this is just within the Milky Way. In the universe, there are many galaxies like the Milky Way. The image you see now is our neighboring Andromeda galaxy. It is also the clearest image of the Andromeda galaxy ever taken by the Hubble telescope. In the rectangular area, the resolution is as high as about 1.5 billion pixels, spanning 41,000 light-years. When zoomed in, one finds dense points of light everywhere, and each of these points is a shining star, numbering nearly 100 million or more. For us, whether it's the Milky Way or the Andromeda galaxy, they feel immensely vast. But when we look further into the vast universe, we find that they are actually just very small galaxies. Next, you will see an even more incredible picture. This photo is a deep space image of the universe taken by the Hubble telescope in 2003, named the Hubble Ultra Deep Field. The area you see now is only 3 square arc minutes, about 1/12,700 of the entire sky's area, equivalent to 1/10 the area of the full moon. Yet it contains about 10,000 galaxies, the farthest being about 13 billion light-years away. If this photo were to cover the entire sky, the number of galaxies in the universe would be at least over 2 trillion. And this is only what current technology can observe, excluding unseen regions. Looking at this picture, one can imagine how vast the universe is and how insignificant humans are. Space is almost a vacuum environment. We cannot hear any sounds because space lacks air, and sound waves cannot travel through vibration. However, this doesn't mean there's no sound in space. In fact, sound exists in space in the form of electromagnetic vibrations. Almost all types of celestial bodies emit some form of electromagnetic radiation, such as pulsars, nebulae, quasars, galaxies, and planets. These electromagnetic signals can be captured by specially designed instruments like astronomical interferometers, which can convert electromagnetic signals into frequencies within the human audible range of 20 to 20,000 hertz. Next, let's learn about the sounds from various celestial bodies in the universe. 1. Pulsars. Pulsars are highly magnetized, rotating neutron stars that emit electromagnetic radiation at extremely regular intervals. 2. Nebulae. Nebulae are clouds of dust and gas in the universe. Under certain conditions, some nebulae can also emit strong electromagnetic radiation. This is the sound emitted by the Helix Nebula. This is the sound emitted by the pillars of creation. 3. Quasars. Quasars are very distant active galactic nuclei. They can be considered one of the brightest known radio wave sources in the universe. 4. Radio galaxies. Radio galaxies are galaxies that emit large amounts of radio radiation. This radiation comes from the material around the supermassive black hole at the galaxy's center. Besides the above, planets in our solar system can also emit electromagnetic radiation. Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. These are all sounds from distant celestial bodies. They not only increase our understanding of the universe, but also provide a unique perspective for astronomical research. Our Sun is a medium-mass yellow dwarf star. Its volume is immense, capable of holding 1.3 million Earths. Its mass constitutes 99.86% of the entire solar system's mass, equivalent to 330,000 times that of Earth. If you were to approach its surface, you would find it exceptionally terrifying, with temperatures reaching 5,600 degrees Celsius. Sometimes intense solar activity phenomena erupt. In its core, nuclear fusion from hydrogen to helium is constantly occurring. Approximately 600 million tons of hydrogen undergo fusion every second, turning into 596 million tons of helium, with 4 million tons of hydrogen converted into energy released. This energy is the light and heat we receive every day. However, the light and heat brought by the sun will not last forever. As fuel is consumed, the hydrogen in the sun will become less and less. Based on its mass, calculations estimate the sun can continue burning for about another 5 billion years. This means that in 5 billion years, the Sun will face its death. Scientists speculate that in about 4 billion years, the Sun will transition from the main sequence stage to another stage, known as the red giant stage. In the red giant stage, the hydrogen in the Sun's core is almost depleted, leaving only helium. The conditions required for helium fusion are higher, meaning the Sun can no longer maintain balance through fusion energy. Thus, this balance will be broken, and gravity will gain the upper hand to resist its own gravity. The core will contract inward, causing temperature and pressure to rise sharply. When the temperature reaches 100 million degrees, helium will trigger a new round of nuclear fusion. The process of helium fusing into carbon. As the core temperature rises, the outer hydrogen layers will expand outward. The Sun's diameter will increase to over 200 times its current size. By then, our Earth, Venus, and Mars will be engulfed by the expanding Sun. Even before that, Earth will be baked by the Sun's high temperatures. Liquid water will completely evaporate, and even the surface will melt into a lava state. Everything on Earth will be destroyed. If you could stand on Earth's surface at that time, you would see an unprecedented giant fireball rising in the east. Earth would no longer be the vibrant world it once was, but rather a hellish apocalypse. However, the red giant stage will not last long, only about 1 billion years. After 1 billion years, as helium is depleted, fusion reactions will cease to release energy. At that point, the Sun will completely disintegrate, and the remaining material will be ejected, forming a beautiful planetary nebula. Ultimately, only an extremely dense white dwarf will remain in the core. This is the fate of the Sun. In fact, in our universe, there are many such dead stars. Depending on their mass, their deaths vary. For stars with masses between 8 and 30 times that of the Sun, they die in explosions due to their larger mass. These stars can fuse elements up to carbon and beyond until they reach iron, then stop and undergo a supernova explosion. After the supernova explosion of such stars, the core mass is generally between 1.4 and 3.2 solar masses. At this point, gravity continues to collapse and compress atoms, forcing electrons into atomic nuclei where they combine with protons to form neutrons, thus forming what we commonly call a neutron star. Betelgeuse, located 640 light-years away, is such a star. It is located in the Orion constellation, a red supergiant with a mass at least 16 times that of the Sun and a volume capable of holding 700 billion suns. If the Sun and Betelgeuse were swapped, its volume would exceed Jupiter's orbit. Currently, Betelgeuse is approaching the end of its life. Astronomers predict it might go supernova within 100,000 years. When it explodes, its luminosity might even surpass that of the full moon, lasting for several months, visible during the day. Then, over a few years, its brightness will gradually fade. At that time, the left shoulder of Orion will lose a star emitting red light, leaving only a dense neutron star. Neutron stars actually have a very small diameter, only tens of kilometers, but their mass per cubic centimeter can reach over 100 million tons. Moreover, their gravity is so strong that even light entering its vicinity must follow a parabolic path to escape. Its escape velocity can reach 50% of the speed of light. However, neutron stars are not the most terrifying. The most terrifying are black holes. Black holes are also products formed after the death of a star. When a massive star reaches its end, if the core mass exceeds 3.2 times the solar mass, that is, beyond the Tolman-Oppenheimer-Volkoff limit, then this core will continue to collapse. Under powerful gravity, neutrons will be crushed into powder and gather at a point, then forming a black hole. Black holes can be said to be the celestial bodies with the strongest gravity in the universe. At their center is an infinitely dense and hot singularity. All matter is compressed into this point. Therefore, its gravity is so strong that any matter entering its gravitational range will be swallowed, including the fastest light, which cannot escape. Its escape velocity exceeds the speed of light. This is also why we cannot directly see black holes with the naked eye, so we can only discover their existence through indirect methods. For example, when a black hole swallows matter, it forms a high-speed accretion disk around it, allowing us to detect its presence. Or by observing abnormal motions of stars, because the black hole's gravity affects stellar motion. If we see a star orbiting an invisible gravitational source, we can speculate that this invisible gravitational source is a black hole. Besides black holes, which we cannot see with the naked eye, there are other things we cannot see, such as dark matter and dark energy. According to modern cosmological models, in our universe, the matter we can actually see only constitutes a tiny fraction, about 4.9%. The rest is 26.8% dark matter and 68.3% dark energy. Dark matter is a completely invisible substance. It does not absorb, reflect, or radiate light. It cannot even be detected on the electromagnetic spectrum, so we cannot perceive the existence of dark matter. Since we cannot perceive it, how do we confirm its existence? Although dark matter does not interact with visible matter, it can produce gravity. As we all know, gravity is the weakest of the four fundamental forces, but it is still a long-range force that can act over infinite distances. The strength of gravity is proportional to the product of the masses and inversely proportional to the square of the distance. Through the law of universal gravitation, we can understand the motion laws of celestial bodies. For example, when a planet orbits a star, the closer the planet is to the star, the faster its orbital speed. The farther away, the slower its orbital speed. This is because gravity decreases with the square of the distance. However, in the 1930s, when astronomers studied the motion speeds of stars within the Milky Way, they were surprised to find that the speeds of stars on the outer edges of the Milky Way were faster than theoretically predicted. That is, according to existing theory, the gravity from the center of the Milky Way should not be able to bind the outer stars. They should fly apart. Therefore, scientists speculated that there might be an invisible substance in the Milky Way providing additional gravity, and this additional gravity is provided by dark matter. Thus, we can detect it through indirect methods. One such method is gravitational lensing. Gravitational lensing is a phenomenon mentioned by Einstein in the theory of general relativity. It occurs when light from a distant galaxy passes near a massive object and bends, forming one or more converging effects similar to a convex lens. This is gravitational lensing. When astronomers observed the universe with the Hubble telescope, they officially found that many galaxies, even galaxy clusters, appeared distorted, with environments spanning millions of light years. This huge lensing effect could not be formed by visible matter, thus indirectly proving the existence of dark matter besides dark matter, which cannot be seen. There is also dark energy. In fact, dark energy is even more mysterious than dark matter. Currently, we know nothing about it. According to current observational evidence, our universe is actually accelerating its expansion. So what energy is causing the universe to keep expanding? Scientists speculate that the culprit behind the universe's expansion might be dark energy. Dark energy is a form of negative pressure energy, equivalent to the opposite force of gravity, playing a repulsive role in the universe. If dark energy did not exist, the universe might only contract under gravity. All galaxies would get closer and closer, eventually gathering matter to a point, becoming the initial state of the universe. Therefore, the universe must have dark energy to maintain itself. Otherwise, everything would cease to exist. However, dark energy causing the universe to expand is not necessarily a good thing. Some scientists have proposed a theory. If the universe continues to expand, the density of dark energy might increase with space. This means galaxies will move farther and farther away from us, and eventually stars, planets, even atoms would be torn apart in the expansion. This theory is the Big Rip scenario for the end of the universe, but the above is merely a conjecture. Whether the universe will truly have an end one day, we may never know. In fact, regarding the universe, there are many questions we cannot answer. For example, one of the most curious is, how large is the scale of the universe? Based on humanity's current understanding of the universe, we note that Earth is the third planet from the Sun in the inner solar system. Closer to the Sun are Mercury and Venus. Starting from outside Earth, in order, are Mars, Jupiter, Saturn, Uranus, and Neptune. Neptune is the farthest from Earth, reaching for 0.5 billion kilometers. Even at the speed of light, a one-way trip would take for hours and 15 minutes. Continuing outward, there is the densely populated Kuiper Belt, a disc-shaped region about 30 astronomical units wide. Beyond the Kuiper Belt is a spherical cloud surrounding the entire solar system, called the Oort cloud. This is considered the edge of the solar system, at least about 1 light-year from the Sun, yet this 1 light-year is a chasm that humanity can never cross in a lifetime. Currently, the farthest human-made probe is Voyager 1, traveling at 17 kilometers per second. It has flown for over 40 years within the solar system and has only reached a position of 23 billion kilometers, equivalent to over 20 light hours. To fly out of the Oort cloud would take at least tens of thousands of years. At this point, we might think the solar system is already vast enough, but in the face of the vast universe, the solar system is actually just a speck of dust in the Milky Way. The Milky Way is a huge collection of stars, with at least 200 billion stars and a diameter of about 160,000 light-years. Furthermore, all stars are rotating around the center of the Milky Way, including our Sun. Our Sun is about 26,000 light-years from the galactic center, constantly moving at 230 kilometers per second around the galactic center. It moves 1 astronomical unit in about 8 days, 1 light-year in about 1,400 years and completes one orbit around the galactic center in about 220 million years. To us, the Milky Way seems immensely vast. However, if we continue to look further, we find that the Milky Way is actually located within a slightly larger collective known as the local group. The local group contains about 50 galaxies with a diameter of about 10 million light-years. Above the local group, there is an even larger structure called the Virgo supercluster. The Virgo supercluster spans a region about 110 million light-years in diameter, containing about 100 galaxy groups like our local group, yet this is not the largest. Above the Virgo supercluster, there are still larger structures, the Laniakea supercluster and the Pisces Cetus supercluster complex, leading up to the diameter of the observable universe. The diameter of the observable universe is the range we can observe, but it is not the actual size of the universe. Due to the limitation of the speed of light, light from beyond has not yet reached Earth. Therefore, we cannot peer into regions beyond 93 billion light-years. This means we can never know the true scale of the universe. So, for such an observable universe, do you know how many galaxies it contains? Regarding how many galaxies are in the observable universe, we cannot know accurately and can only estimate through observations. This is thanks to the work of the Hubble telescope. This photo was obtained between September 2003 and January 2000 by the Hubble Space Telescope's advanced camera, were surveys which took a long exposure shot of a very small region of the universe located in the direction of the southern constellation Phoenix. After 113 days of exposure and about 800 photos, Hubble merged them to obtain this astonishing deep space photo named the Hubble Ultra Deep Field. The Hubble Ultra Deep Field covers only 12,700,000 of the total sky area, but it contains nearly 10,000 galaxies, including the most distant and ancient galaxies, the farthest being over 13 billion light-years away. Later, based on the Hubble Ultra Deep Field, astronomers shot an even smaller region of the sky with a cumulative exposure of nearly 2 million seconds, capturing a more detailed deep space photo. The Hubble Extreme Deep Field, XDF, it reveals even more distant and fainter galaxies, still containing tens of thousands of galaxies. By analyzing deep space photos taken by the Hubble telescope, scientists estimate that if all regions of the sky were photographed within the observable universe, the number of galaxies would be at least over 2 trillion. One can imagine how vast the number of galaxies in the universe is. Looking back at the entire scale of the universe and the enormous number of galaxies, it can't help but make us sigh at how insignificant humans are in the universe. From Earth to the Sun, to the Milky Way, and finally to the edge of the observable universe, each step of expansion greatly exceeds our imagination. Earth is but a pale blue dot in the solar system. The solar system is but a grain of dust in the Milky Way. The Milky Way is just one among trillions of galaxies in the universe. However, although on the grand scale of the universe, Earth seems insignificant, it is precisely this tiny piece of land that nurtured us, bringing us dreams and hope. It has also inspired humanity's courage and determination to explore the unknown and seek the mysteries of the universe. In this journey through the vast universe, Our story ends here, yet for humanity, the exploration of the universe has only just begun. Earth is the cradle of humanity, but mankind cannot stay in the cradle forever. Initially, they will cautiously emerge from the atmosphere and then conquer the solar system. This quote is from the famous saying of Konstantin Tsiolkovsky, the father of astronautics. From ancient times to the present, humans have been fascinated by the starry sky above. Breaking out of Earth and flying into the vastness of space has always been a human dream. However, leaving Earth is not an easy task. It wasn't until the space race during the Cold War between the US and the Soviet Union in the last century that the human space age officially began. Today, let us follow the lens and review the entire journey of humanity's exploration of the solar system. October 4th, 1957. The Soviet Union launched humanity's first artificial satellite, Sputnik 1. The human space age officially began. After 92 days, orbiting Earth 1,400 times, it burned up in the atmosphere. November 3, 1957. The Soviet Union launched Sputnik 2 and sent a dog named Laika into space. Unfortunately, Laika died from overheating a few hours after reaching space, but her brief space journey paved the way for later manned flights. April 12, 1961, the Soviet Union launched Vostok 1. Yuri Gagarin became the first human in outer space. He orbited Earth once at an altitude of 301 kilometers for about 1 hour and 48 minutes, then safely returned to Earth. August 27, 1962. The United States launched the Mariner, the probe to Venus, after 108 days and 290 million kilometers. Mariner flew by Venus at a distance of 34,800 kilometers, becoming the first space probe to approach another planet in the solar system. November 28, 1964, the United States launched the Mariner for probe, the first to the distant Mars. It took 21 photos of Mars from about 10,000 kilometers away, allowing us to see the true appearance of another planet for the first time. March 18, 1965, the Soviet Union launched the Voskhod 2 spacecraft into space. Cosmonaut Alexei Leonov became the first human to perform a spacewalk. November 16, 1965, the Soviet Union launched the Venera 3 probe. After a year of flight, it successfully entered Venus orbit. On March 1, 1966, the lander separated and headed towards Venus, thus becoming the first Earth-made object to reach Venus. December 21, 1968, the United States launched Apollo 8. This was humanity's first manned lunar orbital flight and the first close-range observation of the Moon. The 3 astronauts successfully returned to Earth on December 27 after a 6-day mission. July 16, 1969, the United States launched Apollo 11, humanity's first lunar landing mission. After a 4-day flight, the separated Eagle lander successfully landed on the Moon's Mare Tranquillitatis on July 20th. Neil Armstrong became the first person to set foot on the Moon, saying as he left his footprint, "That's one small step for a man, one giant leap for mankind." March 2, 1972, the United States launched the Pioneer 10 probe. After a flight of over 1 year and 9 months, it became the first to visit Jupiter, the solar system's largest planet, and sent back the first close-up photos of Jupiter. This was also the first time humans saw Jupiter's Great Red Spot. October 3, 1973, the United States launched the Mariner 10 probe, the first to visit Mercury. After over 4 months of flight, Mariner 10 flew by Mercury at a distance of 700 kilometers from its surface, taking many valuable photos. August 20th, 1975, the United States launched the Viking 1 probe to Mars. After a 10-month flight, it became the first to land on the Martian surface and sent back the first color image from the Martian surface. September 1st, 1979. After a flight of about 6 years, the Pioneer 11 probe visited Saturn. It was the first human-made spacecraft to come closest to Saturn and the first close-range observation of Saturn and its rings. January 24, 1986. After 8 years since launch, Voyager to visit distant Uranus. It flew by Uranus at a distance of 81,500 kilometers and discovered 10 previously unknown moons of Uranus, then headed towards Neptune. August 25, 1986. Voyager to reached Neptune. Thus, it became the first human-made probe to reach Neptune. This was the first time humans clearly saw Neptune's true appearance and discovered it also has 5 beautiful planetary rings. February 14, 1990. The famous Voyager 1 probe reached a position 6.4 billion kilometers from Earth. On this day, controllers used its narrow-angle camera to take one last look back at our solar system, capturing a family portrait of the solar system. 2006, the United States launched the New Horizons probe. After a long journey of 9 years, in 2015, New Horizons became the first to visit Pluto, sending back numerous images and data of Pluto and its moon Charon. August 12, 2018, the United States launched the Parker Solar Probe. In April 2021, it successfully passed through the Sun's corona, becoming the first human-made spacecraft to come closest to the Sun. Today, humans have reached all planets in the solar system with probes. The farthest traveled, Voyager 1, has even left the heliosphere and reached a distance of 22 billion kilometers from the Sun. However, our current exploration of the solar system is still just the tip of the iceberg, as the solar system's radius reaches 1 light-year. But it is believed that in the distant future, humanity will surely set foot in more distant, unknown realms. All right, my friend, let's pause our conversation here tonight on the mysteries of the universe. Now, allow me to press pause for you. Set aside all thoughts and inquiries, and simply, quietly be in this moment. From here, my voice will fade away, leaving only the silent tapestry of the cosmos and a carefully chosen piece of pure music tuned to 432 Hz. Science suggests this frequency resonates deeply with the natural vibrations of the universe and the rhythm of life itself, soothing your nervous system and guiding you into deep relaxation. Now, find your most comfortable position. Gently close your eyes or let your gaze rest softly upon the stars. May you release all weariness from the world, letting your consciousness drift on the waves of music, floating into boundless tranquility. Good night, sweet dreams, until we meet again among the stars.